Law of chemical combination. Right? So there are different types of laws which actually on the basis of which we can find out that how the elements combine together, how A plus B combine and form a new compound that is AB with distinct properties. All right. So let's begin with the first law, law of conservation of mass. That law explains that the law of conservation of mass stated that matter can neither be created nor destroyed in a chemical reaction. When we do a chemical reaction, the matter will not create or neither destroy. How this thing happens? For example, if I react S plus Fe gives FeS, means 32 grams of S sulfur plus 56 grams of iron, the total combined form 88 grams of product. It means the mass of the reactant will always be equal to the mass of the product. That is what the law of conservation of mass is. Second one is law of definite proportion. In given compound always contains exactly the same of proportion. It means that if you just calculate the proportion of reactant and the product, it will be same. For example, 3.2 gram of carbon react with 4.0 gram of oxygen and form 7.0 gram of carbon monoxide. With that, 3.0 gram of carbon react with 8 grams of oxygen that will form 11.0 grams of carbon dioxide. So if you just find out the average ratio of mass, that will be for example, that oxygen and carbon ratio is 4:3, and in that oxygen and carbon ratio is 8:3. Okay, so there is a specific ratio. All right. So this is the thing that this Joseph explains that though there is the combination of element in a definite proportion. All right. Second one is law of multiple proportion. If two elements can combine to form more than one compound, the masses of one element that combines with a fixed mass of other element are in a ratio, specific ratio. For example, nitrogen and oxygen combine to form nitrogen monoxide. And nitrogen dioxide, the ratio is 14 is to 32. There the ratio is 14 is to 66. There is a proper ratio on which the elements combine. Next is the chemical law of gaseous volume. When the gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. If you want to combine the gases, what do you have to do the first thing? You have to reduce the temperature. Why? So that the kinetic energy of the molecules reduce and the gases can liquefy easily. And then we will increase the pressure. So there are two specific things which has to be regulated by while performing this experiment on gases, that is temperature and pressure. All right. So this combine the gases or the elements combine to form a specific, you can say, specific compound under specific temperature and pressure. Avogadro law. Equal number of gases contain equal number of molecules at standard temperature and pressure. For example, 2 mole of H2 combined with 1 mole of oxygen, they get 2 mole of H2O. All right. So equal number of molecules means the equal number of gases contains the equal number of molecules at a specific temperature and pressure. Next is important theory, the Dalton atomic theory. The Dalton explains all the things which are related to the atoms, matter, everything he explains. The first point he explained is matter consists of indivisible atoms. The smallest unit of matter is the atom, which is indivisible. It cannot dissociate further. Okay. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Different elements, you can say the different atoms differ in masses. For example, if we take the mass of hydrogen and oxygen, both have different masses. So the mass associated with the elements are different. Different atom possesses different. Compounds are formed when atoms of different elements combine in a frequency. How the compound form? When the different elements combine together and form a new compound, and that will be in a specific ratio. Alright, so that is compound. Chemical reaction involve reorganization of atoms. These are neither created or not destroyed in a chemical reaction. What actually happened in a chemical reaction? There is a reorganization of atoms and molecules. Right? Means there is a reorganization. They changes their place, but we cannot create the atom or we cannot create any element. Only what we can do, we can form different compounds by reorganizing these elements. Right? Atom now we'll discuss what is atomic mass and the molecular mass. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of carbon. 12 atom is equal to 1 AMU. That will be 0, that will be 1.66056 into 10 to the power minus 24 grams. Alright. So today the AMU is has been replaced with the U. So U specify what? The atomic mass of the specific atom. Okay. So now this AMU has been replaced with U. That means the unified mass. Right? So what is the average atomic mass? From the above data, for example, if we talk about the average atomic mass, the carbon, we have three allotropic form of carbon, carbon 12, carbon 13, and carbon 14, and they have different masses. So what is the average atomic mass? So if we find out the average atomic mass of carbon, so that will be 12.01. We just find out how we just calculate and take an average for each and every carbon atom, because it is not possible for us to identify that about which carbon form they are talking or which carbon form is participating in any reaction. So we just took average value, that will be 12 for the mass of carbon. Molecular mass. The molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. For example, how you can find out the molecular mass. For that, you have to learn the atomic masses of all the elements. That after that, you will be able to calculate the molecular mass. So, for example, if I have a molecule that is methane, so the carbon and hydrogen are there. Okay, so 12 is the atomic mass of carbon. Just now we have calculated 1.008 U is the mass of hydrogen, and since we have four hydrogen molecules here, so after multiplying this, that 4 with 1, that is 4 with the 4, and 4 plus 12 is 16.43 U is the atomic mass, or you can say the molecular mass of the molecule. Similarly, if we talk about the water molecules, so what happens? We have two molecules of hydrogen and one molecule of oxygen. And since we know the atomic mass of hydrogen is 1.008 U, plus we have the mass of oxygen, that is 16 U, and two molecules, 2 1 2 plus 16, that will be equal to 18.02 U. So the atomic mass of water molecule will be 18.02 U. Similarly, we will calculate the formula mass. How? Some substances such as sodium chloride do not contain discrete molecule as their constituent unit. In such compounds, positive sodium and negative chloride entities are arranged in three-dimensional structure. It may be noted that in sodium chloride, one Na positive is surrounded by 6Cl or vice versa. This formula, such as NaCl, is used to calculate the formula mass instead of molecular mass, as in solid state sodium chloride does not exist as a single entity. Thus, the formula mass of sodium chloride will be atomic mass of sodium plus atomic mass of chlorine. That will be 23.0 U plus 35.5 U. That gives 58.5 U. So the mass of sodium chloride, the common salt, or you can say the NaCl, will be 58.5 U. Alright. There is another term that will be mole concept. One mole is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 grams or 0.01 gram kg of the 12 carbon isotope. The mass of carbon, 12 atoms, determined by mass of spectrometer and found to be equal to 1.992648 to 10 to the power minus 23 grams. Knowing that 1 mole of carbon weight is 12 grams, 1 mole of carbon weight is 12 grams, the number of atoms will be equal to 12 upon the same value. And when we divide it, so it will be equal to 6.22136 into 10 to the power 23 atoms per molecule. Okay, so 1 mole, the value of 1 mole is equal to 6.022. You can take it to up to 3 places after decimal into 10 to the power 23 atoms per mole. We can therefore say that 1 mole of hydrogen will be equal to this one. Okay, so 1 mole of water molecule will be equal to 6.022 into 10 to the power 23 water molecule. The mass of one molecule of a substance in gram is called its molecular mass. So if you want to find out what is the molar mass, sorry, not molecular, it's molar mass. So the mass of 1 mole of substance in grams is known as the molar mass. The molar mass in grams is numerically equal to the atomic, molecular, and formula mass in U. The molar mass of water is 18.02 grams per mole. Molar mass of sodium chloride is 58.5 gram per mole. Alright, so that is how we find out. So let me just give you an example of, let's just learn this thing with an activity. Classify the following as pure substance or mixture. Also separate the pure substances into elements and compounds, divide mixtures and homogeneous categories. This is the actually some examples are there. You have to just segregate these things into pure substances, elements, compound, homogeneous, heterogeneous, and send me in the chat box. All right, do it fast. Okay, so let's talk about the limiting reagent. When any reaction is carried out, if the reactants are not present in the amount as required by a balanced chemical reaction. In such situation, one reactant is in excess over the other. The reactant which is present in the lesser amount get consumed after some times, and after that no further reaction will take place. Whatever be the reaction, or you can say whatever be the amount of reactant present. So what happens when we perform an activity, when we perform a reaction? What happens? So one among all the reactants just limit off, and after a period of time, it will vanish, and the reaction ultimately stops. So that is the limiting reagent. So hence, the reactant which get consumed limits the amount of product formed and is therefore is known as the limiting reagent. So you can say limiting reagent, the reagent, or you can say the reactant used up first in the chemical reaction. And another one will be the excess reagent. Excess reagent means the reactant present in quantities greater than necessary to react with the quantity of the limiting